In the second video on advanced manufacturing and cybersecurity, we'll talk about advanced manufacturing, cyber threats, and mitigation strategies. This video was brought to you by the National Cybersecurity Training and Education Center out of Whatcom Community College. NCyTE Center in this material is based upon work supported by the National Science Foundation. My name is Philip Kreger. I am a professor of cybersecurity at Embry-Riddle Aeronautical University in Daytona Beach, Florida, and also a co-PI for NCyTE. So as an overview, we'll first do a very quick review of key points from the previous video, and I actually highly suggest that you go back and watch the first video because there's some terms that I'm not going to be explaining in here that were defined in the first video. Then we'll talk about cyber threats to something called operational technology, which is different from information technology. And operational technology is used in manufacturing. And in particular, we'll concentrate on the industrial Internet of Things and cloud-based control systems. Then we'll look at some incidents of cyber attacks on operational technology and advanced manufacturing. And then we'll look at some risk mitigation strategies and controls for cybersecurity and manufacturing that are woven throughout this presentation. The Cybersecurity and Infrastructure Security Agency, or CISA, has identified 16 critical infrastructure sectors. One of these is critical manufacturing. The critical manufacturing sector is crucial to the economic prosperity and continuity of the U.S. A direct attack on or disruption of certain elements of the manufacturing industry could disrupt essential functions at the national level and across multiple critical infrastructures. In the previous video, we defined advanced manufacturing. Advanced manufacturing involves the use of automation technology to improve products and processes. If we look back at our parents' or our grandparents' era and we look at the manufacturing that was done then, it looks totally different than it is now. Back then, there was nothing that was automated with digital technology. Everything pretty much had to be done by hand. But now with the advent of information communication technologies and in the Internet of Things, now we were able to provide a more secure and a more robust and a more efficient set of manufacturing processes, including things like robotics, sensors, computer-aided design, computer-aided manufacturing, and 3D printing as you see there in the graphic. And some of the technologies that are now being used include things such as SCADA, which stands for Supervisory Control and Data Acquisition, ICS, or Industrial Control Systems, Programmable Logic Controllers, Sensors, and Cyber Physical Systems. In that last part, the cyber physical systems is going to be key when we start discussing operational technologies because we're no longer talking about just simply computers and networks, but now we've introduced physical systems into that infrastructure. I've discussed, all of these terms are discussed in more detail in the first video. So as we saw in the first video, there's the changing nature of manufacturing to something that more aligns with something called digital manufacturing. Manufacturing has moved from analog, that is manual labor, paper and pencil design, to being digitally driven with information communication technologies and chips and networks. That is networks of computers, automated machines, ubiquitous sensors, and technicians whose job is to convert digital data into physical parts and assemblies. The design, manufacturing, and product support operations are driven by a digital thread of technical data, product and process information that can be shared throughout the supply chain and must be protected. If you're unfamiliar with the term supply chain, I have a series of videos that talk about the supply chain and cybersecurity. So much attention has been given to protecting technical information and information technology, or IT systems and networks. And if you're in a cybersecurity program or an information technology program, these are really what we're talking about. We have computers, we have networks, we have data storage, and we have information. That's what we're trying to protect. But now when we start talking about CPS, or cyber physical systems, there is a different need to protect the aggregation of both the information technology and the operational systems of a manufacturing enterprise, which present a new and different set of challenges. Not only must the technical data be protected from theft, it must also be protected from alteration that could impair the proper functioning of parts produced or affect the safety and availability of the production system, that is, the machines that are actually making these parts. One of the crucial things that you need to take from these series of videos is that business information technology cybersecurity, really what most of us study, the needs for that are not the same as manufacturing operational technology cybersecurity. While they may be similar, they're not exactly the same, because now we're talking about not only cyber physical systems, but as we'll see shortly, there's other areas within operational technology that are things that we really don't study when we're talking about the normal computers, networks, and information communication technologies. But that's what this video is for, to introduce you to those concepts. In the last video, we looked at the separation of components within the advanced manufacturing domain into the IT infrastructure, that is the things that we normally study in IT programs and cybersecurity programs, as opposed to the operational technology or OT infrastructure, which now includes things like SCADA, programmable logic controllers, and sensors and the machines, all which go into the manufacturing of components or other systems. And this includes things like computer-aided design, CAD, computer-aided manufacturing, CAM, and computer-aided engineering, CAE. With the introduction of the Industrial Internet of Things, or IIoT, the IT-OT air gap is rapidly dissolving. And by air gap, that just means that things are physically separated. IIoT devices enable industrial processes to be remotely monitored and managed from a central location, allowing organizations to achieve greater efficiency and productivity. And while the graphic on the screen does show that these domains are physically separated, the IT versus the OT, they actually have a relationship between those because there's information flowing in between the IT infrastructure and the OT infrastructure. Therefore, if that's the case, then that means that some of that connection could serve as a jumping off point for an attack or a threat vector by a malicious actor. Now let's look at some cyber threats to advanced manufacturing. And I want you to note, even because we're now talking about something called operational technologies, and it's not the same thing as information technology, and I've introduced some new terms like SCADA and PLC and ICS, still, since advanced manufacturing relies upon computers and networks, a lot of what you've learned in your IT and cybersecurity classes applies to advanced manufacturing. So let's first look at an advanced manufacturing cyber study. A cyber study by Deloitte Center for Industrial Insights found that 1/3 of manufacturers haven't performed cyber risk assessments for their industrial control systems. 2/3 have used internal resources which could potentially lead to bias. And what that means is when you're looking at your own systems, sometimes that you may miss things. And that's why doctors are not supposed to diagnose their own illnesses. Usually they go to another doctor so that you remove that potential personal bias. 43% of manufacturers use isolated networks through network segmentation and air gapping, that is that physical gap. And this is a common approach to industrial control system cybersecurity. So essentially those ICS systems are not directly connected to the internet, but as we'll see, advanced manufacturing is actually moving toward that and removing that air gap. The lack of control of live network access points and easy to install wireless can be hidden. And one of the reasons that this air gap is really slowly being reduced is that cutting access to the outside world through the internet may limit cost savings and efficiency benefits. Remember that businesses are in business to make money, to thrive and to grow. And therefore, when there is some way to increase cost savings and efficiency, it would behoove the manufacturer to move in that direction, which essentially means you're opening up the company to more potential cyber vulnerabilities and threats. One quarter reported that incident response programs, that is a team that has a series of procedures and protocols to deal with a cyber event, don't include industrial control systems. And finally, 1/4 of the manufacturers in this study reported they do not develop, implement, or document industrial control system specific policies and procedures. Now here's some potential threats. And if you look on the left, we have an attack. In the middle, we have a method. And on the right, we have the consequence of the event. So potential types of attacks or threats include accessing the network through password attacks or port scanning, which could result in the loss of confidential information. And let me say as an aside, in the previous video, I discussed the CIA of cybersecurity, confidentiality, integrity, and availability. And if you aren't aware what those terms means, I would suggest you go back and watch that short video. You also have denial of service attacks, which can result in the operational disruption or the loss of productivity. You have human in the middle attacks, which can result in physical damage, poor product quality, injury or death, and loss of confidential information. Now, let's concentrate on that for a second. I don't think I've ever seen a class in cybersecurity information technology that talked about physical damage or injury or death. And that's where operational technologies and these cyber physical systems come in, is that there is the potential for physical damage, not only to the machines, but also to humans, or injury or death. And that's why securing these systems is of critical importance. There's also malicious software such as Trojans and viruses and worms, which can result in operational disruption or loss of productivity, again, physical damage or poor product quality, or again, injury or death. And finally, there's data manipulation, which can result again in physical damage, poor product quality, or injury or death. Now, a little later on in this video, I'm actually going to show you examples, a couple of examples of physical damage and the potential for injury that's based upon cyber-physical systems and industrial control systems. So let's delve a little deeper into what makes digital manufacturing unique. So advanced manufacturing makes use of something called the Industrial Internet of Things, or IIoT, cloud computing, advanced robotics, and machine learning, or other forms of artificial intelligence. Now again, I'm not going to define machine learning or artificial intelligence, but I do have a series of videos that discuss in more detail artificial intelligence and machine learning, so I'm going to point you to those if you're more interested in those subjects. Each of the above has the potential to become a threat or an attack vector. The manufacturing sector is among one of the most frequently targeted industries, second only to healthcare. And this is due to the IIoT connected machines and cloud-based remote sensing and control systems. So what we have to do now is look a little more deeply into IIoT and cloud-based control systems. So you're probably aware, hopefully, there are things called Internet of Things. So let's distinguish between Internet of Things and Industrial Internet of Things. So the Internet of Things, or IoT, is a system of interrelated computing devices, mechanical and digital machines, objects, or even animals or people that are provided with unique identifiers and the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. So what does all that mean? Do you all have any IoT devices in your house or your dorm room or wherever you live? Well, let's take a look at some examples. So here we have the Ring doorbell. And the Ring doorbell is a digital device that's connected to the internet and that can be controlled with a smartphone. We also have the Nest thermostat, which allows you to control the heating and cooling in your house, which is also connected to the internet and can be controlled with an app on the smartphone. We have Amazon Alexa and all other different types of smart assistants, which is connected to the internet. We have digital and smartwatches. Did you know that your smart TV is actually an Internet of Thing? That too is connected to the internet and can be controlled with an app. Did you know that there are things called smart refrigerators? I'm not sure why you would want one, but I'm guessing in 10 years that's the only thing you would be able to buy. And there's even smart microwaves. And this is just a handful of different examples of things called the Internet of Things. So the Industrial Internet of Things is the intersection of IT, information technology, and operational technology, OT. Operational technology refers to the networking of operational processes and industrial control systems, including human-machine interfaces, and we'll talk a little bit more about that shortly. Supervisory control and data acquisition, distributed control systems, and programmable logic controllers. Again, if you want to know a little bit more about those, please see the first video in this series. The convergence of IT and OT provides industries with greater system integration in terms of automation and optimization, as well as better visibility of the supply chain and logistics. The consistent capturing and transmitting of data among smart devices and machines provide industries and enterprises with many growth opportunities. The data allows industries and enterprises to pick up on errors or inefficiencies in the supply chain, for example, and immediately address them, thus pushing for day-to-day efficiency in operations. By adopting connected and smart devices, businesses are enabled to gather and analyze greater amounts of data at greater speeds. Not only will this enhance scalability and performance, but it can also bridge the gap between the production floors and general offices. Integration of the IIoT can give industrial entities a more accurate view of how their operations are moving along and help them make informed business decisions. With IIoT implementations, 3 areas need to be focused on: availability, scalability, and security. Availability and scalability may be already second nature to industrial operations, since they could already have been established or in business for quite some time. Security, however, is where many can stumble when integrating the IoT into their operations. Also, the proliferation of smart devices has given rise to security vulnerabilities and the concern of security accountability. IIoT adopters have the de facto responsibility of securing the setup and use of their connected devices, but device manufacturers have the obligation of protecting their consumers when they roll out their products. Many security problems associated with the IIoT stem from a lack of basic security measures in place. Security gaps like exposed ports, inadequate authentication practices, and obsolete applications contribute to the emergence of these risks. Combine these with having the network directly connected to the internet, and more potential risks are invited. So here's some example of mitigation strategies and controls for the industrial Internet of Things. First, security operations centers are critical in proactively monitoring and defending against the broad range of threats that affect connected environments. Also needed are consistent monitoring and detection in case of malware infection, better threat visibility and early detection of anomalies, proactive prevention of threats and attacks between IT and OT, secure data transfer, primarily meaning encryption, a next-generation intrusion prevention system to prevent attacks from exploiting vulnerabilities. This is just a few of the examples of trying to deal with vulnerabilities and threats within the operational technologies paradigm, which of course is exacerbated by then connecting IT with operational technologies through the Internet of Industrial Things. Now let's look at another technology that is increasingly used by advanced manufacturing, and that includes cloud-based sensing and control systems. And I'm guessing that most of you know what the cloud is or what a cloud is in terms of information technology, but just in case you don't, let's go through a short example. Probably most of you, if you're in school and you're taking a class, use one of these products. You use Microsoft's OneDrive, or you may use Dropbox, and both of those are used to store files. Or you may use Gmail for sending and receiving email. Or you may use Microsoft 365, so you can use Word and PowerPoint and Excel and so on. Note that each of these products is running in the cloud. Those web-based applications are not necessarily running on your computer. They are stored and run in the cloud, which simply means that they're running on somebody else's servers. They're not installed on your computer or locally. So cloud computing is the delivery of on-demand computing services, including applications and storage and processing power, typically over the internet and paid for on a pay-as-you-go basis. Computing services are very diverse. They may include servers, storage, databases, networking, software, analytics, and even intelligence algorithms. Rather than a company owning their own computing infrastructure or data centers, these companies can now rent access to applications, databases, networking, and storage from a cloud service provider. And examples of cloud service providers, which includes infrastructure, software, or entire platforms, includes Amazon Web Services, or AWS, IBM, Microsoft, and Google, just to name a few. In terms of cybersecurity, the average enterprise organization experiences 31.3 cloud-related security threats each month, a 27.7% increase over the same period last year. Notice this is from 2019. Broken down by category, these include insider threats, both accidental and malicious, privileged user threats, and threats arising from potentially compromised accounts. So let's go a little deeper into those threats. So in terms of insider threats, organizations experience an average of 14.8 insider threat incidents each month, and 94.3% of organizations experience at least one per month on average. Now, if you don't know what an insider is, it's pretty simple. It's somebody who's working for the company and who has logical and physical access to the computing environment. Also, compromised accounts. Organizations experience 12.2 incidents each month in which an unauthorized third party exploits stolen account credentials to gain access to corporate data stored in a cloud service. Privileged user threats. Privileged user threats occur monthly at 58.2% of organizations, with organizations experiencing an average of 4.3 each month. These threats can take different forms, ranging from an administrator accessing data in an executive's account to modifying security settings in a way that unintentionally weakens security. Now, we've talked about 3 of the risks thus far. If you think about it, all of the risks we've seen thus far are probably things that you discussed in your IT or your cybersecurity classes. So there's nothing new about these. Now we're just talking about the fact that cloud computing environments may have the same types of risk issues. And then there's a new one called Cloud Threat Funnel. The average organization today generates more than 3.2 billion unique transaction and cloud services each month, such as a user login, upload a file, edit a document, and so forth. With this volume of data, it would be impossible to manually search through an audit trail of user activity to identify potential threats. So if you want to know a little bit more about how that last issue could be mitigated, I would suggest that you go and watch the 2 videos on artificial intelligence and machine learning to know how to automate these processes when you have a lot of data, an overwhelming amount of data. So mitigation strategies, well, the interesting thing here, and the reason I put this question mark here, is that the company who is purchasing the services of a cloud provider isn't in charge of anything. All they're doing is paying for the service, which means that it's really up to the cloud provider to do their due diligence in terms of cyber threats and cyber risks. One of the things that can be done is the executives for the company that are paying for the cloud service can question how they can be assured that these service providers are keeping up with the necessary system upgrades and security patches necessary to keep individual company data safe and secure. Nevertheless, smaller companies could realize some benefit from moving their data to the cloud, as they may not have access to modern security tools otherwise. And finally, this will increase the need to engage service providers in a coordinated dialogue on management and monitoring of key cyber risks focused on the needs and unique issues of the manufacturing sector. Now, let's discuss cyber attacks on advanced manufacturing. Remember earlier I talked about physical damage and possible injury or death? Let's look at some attacks that are affecting physical safety of workers. As pointed out by Deloitte Center for Industry Insights, hacked systems on the shop floor could be manipulated to cause a number of catastrophic events. To date, the most high-profile example of this type of incursion is the steel mill in Germany, where hackers effectively disabled the fail-safe governing one of the plant's blast furnaces, causing widespread damage and endangering the lives of plant workers. You probably don't know what a blast furnace is. This is a blast furnace. So you can imagine that any type of changes in the parameters or any type of disruption in the system could cause physical damage, perhaps to building, perhaps to equipment, or even people. Now let's discuss what I call the mother of all cyber attacks on advanced manufacturing, which deals with uranium enrichment facilities and centrifuges in the Natanz uranium enrichment facility in Iran. This was called Stuxnet. This is the Natanz uranium enrichment facility in Iran. This is where raw uranium is processed using centrifuges that spin at precise velocities. And you see each of those metal cylinders there on the right, those are something called centrifuges. Now these centrifuges take the uranium and they spin at either hundreds or thousands of revolutions per minute at very precise velocities, and the purity of uranium will determine the use of the uranium, because if it's very pure, you can use it not only for a nuclear power plant, but you can also use it for a nuclear bomb. And so Stuxnet was malware, and it was according to cybersecurity researchers, it was the most complicated piece of software ever written. Once the human-machine interfaces, that is, the computers that were controlling these centrifuges, were infected with Stuxnet, the malware would change the display that the technicians were looking at, while at the same time, they would either lower the revolutions per minute of the centrifuges or increase them above their tolerances, which actually led to the physical destruction of some of these centrifuges. Now, the interesting thing is Stuxnet took advantage of a vulnerability in the Windows operating system, which allowed it to jump from computer to computer, that is, from human-machine interface to human-machine interface, which meant that it was essentially a worm. And so it was able to infect all of the computers on the network that were being used as human-machine interfaces for these centrifuges. Now, I'm not going to get into the political details of this, but suffice to say, there is a very good documentary on Stuxnet, and it was out on YouTube, and it might be on Amazon Prime or Netflix, but it's called 0 Days. And I would highly suggest you go watch that, even if you have to pay a little money in order to do that. It's a very good video, but it goes into detail about everything from the start to finish in regards to Stuxnet. I will mention one more thing. Stuxnet was written most likely by a nation state, that is a country, and it was meant to delay or reduce the capability of the Iranians to enrich their uranium. What happened was, though, it actually ended up escaping the facility. Oh, and by the way, this facility was air-gapped. Some way, Stuxnet was able to jump the air gap and go on to infect other industrial control systems of a similar nature, all around the world. And that's actually why we know about Stuxnet, because it escaped. Stuxnet destroyed almost 1/5 of Iran's nuclear centrifuges by infecting over 200,000 computers and causing 1,000 machines to physically degrade. Other examples where physical destruction were possible. A cybersecurity research team demonstrated how cyber attacks on an industrial robot can be successfully executed. In the first attack, the attacker altered the control system of the industrial robot so that the robot moves inaccurately. This attack resulted in defective parts. In the second attack, the attacker changed the calibration parameters of the robot, reducing the positioning accuracy of the robot significantly. In the third attack, the attacker manipulated the program used by the robot, introducing defects in a workpiece. In the fourth attack, the attacker manipulated the status information of the robot. This attack may result in operator injuries. So in summary, we know that manufacturing is moving from a purely physical to a combination of a digital process, physical process using computer physical systems, information technology, and operational technology. The increased use of industrial Internet of Things and cloud-based systems in advanced manufacturing will lead to potential vulnerabilities and accompanying cyber threats and risks. And finally, industries must remain vigilant to new and evolving threats when it comes to operational technologies. This video was brought to you by the National Cybersecurity Training and Education Center out of Whatcom Community College.